How are new biomarkers used to diagnose Parkinson's? Imagine catching Parkinson's disease early enough to make a real difference. That's what new biomarkers are helping us do. These biological indicators are changing how we diagnose Parkinson's by revealing what's happening inside the body at a molecular level. They are measured through blood tests, cerebrospinal fluid analysis, and tissue biopsies, focusing on specific changes linked to Parkinson's disease. One exciting development involves RNA-based blood biomarkers. Scientists have created blood tests that detect certain transfer RNA fragments, or TRFS. In Parkinson's, the ratio of nuclear-derived TRFS increases, while mitochondrial TRFS decrease because of mitochondrial dysfunction, which is common in Parkinson's. These tests can identify people in the very early stages, even before motor symptoms appear, with about 86% accuracy. They use standard laboratory techniques like quantitative polymerase chain reaction, making them practical for clinical use and potentially allowing diagnosis years before symptoms show up. Another promising biomarker involves alpha-synuclein, a protein that tends to misfold and form abnormal clumps in Parkinson's disease. New tests use advanced technology called immunoinfrared sensor technology to detect these misfolded proteins in cerebrospinal fluid. These tests have over 90% sensitivity and specificity, meaning they are very good at identifying true positives and true negatives. Detecting misfolded alpha-synuclein helps confirm a Parkinson's diagnosis early and can also provide information about how the disease is progressing or responding to treatment. There's also a technique called alpha-synuclein seed amplification assays, or alpha-synuclein SAA. This method amplifies tiny misfolded protein seeds from samples like cerebrospinal fluid or skin biopsies. It can detect Parkinson's-related pathology even before symptoms appear. Large studies have validated this test, and it has received support from the Food and Drug Administration for research and clinical trials. It is especially useful for distinguishing Parkinson's from other neurodegenerative disorders and for tracking how the disease develops over time. Researchers are also exploring multiple biomarkers in blood and urine. These include inflammatory markers like C-reactive protein, growth factors such as insulin like growth factor 1, and metabolic enzymes like aspartate transaminase and alanine transaminase ratios. These molecules help us understand the underlying processes of Parkinson's and may lead to more personalized diagnosis when combined with genetic information. Using these biomarkers offers many benefits. They can detect Parkinson's earlier than ever before, sometimes even before motor symptoms start. They improve our ability to tell Parkinson's apart from other similar conditions, making diagnosis more accurate. They also help doctors monitor disease progression and how well treatments are working, leading to more tailored care. Plus, in research, biomarkers can make clinical trials more efficient by identifying suitable participants and measuring biological effects more precisely. In summary, new biomarkers are opening a new chapter in Parkinson's diagnosis. They focus on detecting molecular changes like RNA fragment ratios and misfolded alpha-synuclein in accessible fluids and tissues. While many of these tests are still being validated, they hold great promise for earlier, more accurate diagnosis and better disease management. Remember, always consult healthcare professionals for personalized advice, as individual experiences with Parkinson's can vary widely. These advances are helping us move toward a future where Parkinson's can be diagnosed sooner and managed more effectively.